Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we're going to talk about the distance formula. And before we talk about the distance formula, I'm going to remind you about the midpoint formula. Remember that the midpoint is a point on a segment that divides that segment into two perfect halves, hence the midpoint. Does anyone remember off the top of their heads the midpoint formula? Yes, sir.
X2 plus X1
Okay.
over 2,
Okay, x1 plus x2 over 2, correct?
Y2 plus Y1 divided
Comma y1 plus y2 over 2. Very awesome. Very good. The midpoint is a point. It is an x and y coordinate. So basically, it's the average of the x's, comma, the average of the y's. That's what the midpoint really is. Okay? They give you 2 points. You take the sum of the x's, of both points of the x's, divide that by 2. You take the value to the y's, and you divide that by 2 as well. Okay? So that's the midpoint formula. Now, distance. There are 2 kinds of distances. Okay? Actually, if I want to be technical, 3 kinds of distances. There's a distance that involves rate and time. That's distance equals rate times time. You know, like if you're going 50 miles per hour, how far did you go in 3 hours? You multiply your rate, which is 50 miles per hour, times 3 hours, that'd be 150 miles. We're not going to be talking about that particular distance. We're going to be talking about non-horizontal or non-vertical line distance. And I'm also going to give you the distance for vertical lines and horizontal lines because I want you to be able to differentiate between the two. So distance between any 2 points, whether it is on a horizontal or vertical line or not, usually this distance formula is used for a line that has a slope to it. Okay? If I want to find the distance between, for example, this point and this point, unfortunately, I can't just count. It's not a horizontal or a vertical distance. I can't just count it. So I use the formula x2 minus x1 squared plus y2 minus y1 squared. And that is all in a square root. This is a very important formula. You're going to use this time and time again. So might as well learn it today, okay? Very simple, very easy to use, but very important. And then the other kind of distance that I want to share with you, we've talked about this before, is the distance between 2 points, but that being on a vertical or horizontal line. So what am I talking about here? If I have a straight line, let's pretend that it's perfectly straight, okay? And I say that this is 2 and whatever, this is 11, okay? It's simply the absolute value of the first minus the second, or the second minus the first. It doesn't really matter, as long as it's an absolute value. So 2 minus 11 or 11 minus 2, it's going to be 9 or negative 9, but absolute value of that would be 9, because it's 9 units away. So if I'm on a vertical or horizontal line, just go ahead and subtract those 2 values, and make sure that it's an absolute value because it's a positive distance. But if I'm talking about the distance of non-horizontal or non-vertical lines, I'm going to use the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's distance in a nutshell. Literally, that's the lesson. Now, I want to show you a couple things about how distances work here, okay? When I have a right triangle, okay? I have a right triangle. Let's investigate this a little bit. Bless you. I have this point here, 0A, and I have this point here, B0, okay? Sometimes they'll give you these 2 points and say find the distance. Now, you can use the distance formula. Or you can create a right triangle here, guys, and then use the Pythagorean theorem. So if I go ahead and find this vertical distance, and then I find this horizontal distance, and I take the vertical distance, square it, plus the horizontal distance and square it, and then find the square root of that, I'm going to find my distance here. So you can create a right triangle if you want to get away from doing the distance formula. Okay? As far as an isosceles triangle goes, remember that an isosceles triangle, you have the two legs that are congruent. Okay? Remember that the base of the isosceles triangle is going to be a horizontal line. So that's a very simple distance to calculate. Please remember that since I have an isosceles triangle here, if I go ahead and drop an altitude here, I create a perpendicular bisector, making this guy congruent to this guy. Okay? So I can find all sorts of distances here. Now what I've done is I've created two right triangles. So if I have two right triangles, again, I can go back to finding the horizontal length, the vertical length, squaring the sums of both of those, taking the square root of that, and then I can find the actual hypotenuse if I don't want to use the distance formula. You with me here? So a lot of times you'll have a situation where you have an isosceles and you have to figure something out, a value of some sort. Guys, you can legally drop down an altitude. How is that mathematically legal, Mr. Morrow? Aren't lines made up of points? So can't I have a point here and a point here, which is my vertex? Can't I connect those two? You with me there, guys? So if I make an altitude, that's a 90 and that's a 90 as well, correct? So what I did is I just created a perpendicular bisector. So I cut that base into perfect halves. Okay? Remember that if they're dealing with rhombuses or rhombi, remember that opposite sides are congruent. Opposite sides are congruent. So if I gave you a situation where I told you, find the perimeter of this rhombus, you do not have to find the distance of all four sides. You just need to find the distance of one side and double it because you know the opposite side is equal. And then find the distance of the other side and double it because you know that opposite sides are equal. Yes, sir. It does have all. You're right. Why am I even being so stupid? A rhombus has all equal sides, so all you need to do is find one and quadruple it. Duh. Sorry. What I had just showed you there before, like a ding-dong, was for a parallelogram. Now, I want you to understand the power of being able to make right triangles here as well. If I want to find this distance, and for whatever reason, I forget the distance formula, well, count up your vertical distance, count over your horizontal distance. Now you made a right triangle. So this value plus that value, squared, each of those, is going to equal the square root of this triangle. It's going to equal that value squared. So just take the square root of both sides, and you will have your hypotenuse. Yes, sir. I mean, it's 6 to 1, half dozen to the other. The question was, it's easier to use a Pythagorean theorem. Not really for me. For me, I'd rather just plug it in and be done with it. Now, this is like a last case scenario. I try to always teach you guys things to fall back on. We're human. You forget. So, for example, let's say that we wanted to find this and we forgot. Okay, this is up 1, 2, 3, 4, and this is 1, 2. So that's 4 and 2. So I know that 4 squared plus 2 squared must equal, let's call this a squared. So I've got 16 plus 4, that's 20 equals a squared. Take the square root of both sides, so that's 2 square root of 5 would equal my a. That's That's easy enough, but you had to draw the triangle, and then you had to do the Pythagorean theorem. For me, it would have been easier just to plug in the distance. But again, let's say you forget. You're stressed out, you forget, you're under pressure, you're running out of time, and you just blank out. This gives you something to fall back on. Okay? And then, of course, we have a rectangle here. And the rectangle is similar to the parallelogram, but even easier. You don't really need a distance formula here. You have a vertical distance, which I can double, and then you have a horizontal distance, which I can double. The problem occurs here is if they give you a rectangle and it's slanted. In that case, same thing. Find one side, double it. Find the other side, double it, and then you'll be able to get your perimeter or area or whatever it is that they're asking for. Yes, sir. Yes, sir. Correct. Anytime you can, and with just about any figure, you can create a right triangle.
You could even do that when it's 90 degrees. One of the sides is,
I don't understand what you're talking about.
how the sides are 90 degrees, like an angle.
In a rectangle, for example?
How would you do it here?
Okay, well, let's say that we had a rectangle here. Okay, and then let's go ahead and take this guy and go like this. Okay, I can make my vertical distance, and then my vertical distance. So I have my vertical distance, my horizontal distance, and I take my vertical squared plus my horizontal squared, and that will equal my hypotenuse squared. No, that's okay, man. You're very welcome, my brother. Now, if it's just like this, yeah, you're not going to create a right triangle because I can just count the actual distance, right? Right? For example, this is 1, 2, 3. That's 4 units. This is 1, 2, 3, 4, 5, 6, 7, 8 units. When it's horizontal or vertical, you just count. Or if it's really long and you don't want to count 30 units, just take the first unit, subtract it from the last, make sure it's an absolute value. That's why I taught you the second distance formula for horizontal or vertical lines. You with me? Thank you, sir. Okay, so let's get to this, guys. Find the distance of A, B. Okay, cool. Distance is going to equal the square root of label. I know I'm a pain in the butt, but it's so much easier to just label it, take 2 seconds, and not mess up. A lot of times people mess up not because they don't know the formula, it's because they plug in the wrong things. So 7, which is x2, bless you, minus 2, which is x1 squared, plus y2, which is 15, minus y1, which is 3, squared. So 7 minus 2 is 5 squared, that's 25. Plus 15 minus 3 is 12. 12 squared is 144. That's going to be the square root of 169, which equals 13 units, whatever those units may be. Okay, if you want to draw this out, I guess technically yes. I would not suggest that. No, I know what you mean by draw it out and then create a right triangle. I would not suggest that. What if they give you something like 2, 3.75? How are you going to draw out 3.75? You won't be able to accurately. And then your horizontal and your vertical are not going to be accurate. You only create those right triangles, in my opinion, when they give it to you already on a graph. And you can already go ahead and just fill in the horizontal and the vertical. But I would not, me personally, I would not graph these. No, that's not going to work. But you'd have to, but then, okay, but if you're subtracting, then you're using the formula. What would the point be then? You'd be wasting your time by drawing it at that point, sir. Does that make sense? See, I'm asking. I know what you're asking, though, bro, and I appreciate it greatly. Pretty easy, right, guys? Hello?
Yeah.
Okay. Find the distance of FM here. Okay. Pretty simple. Yes, sir.
Can't assume like a right angle, right? So
No, you cannot assume that that's a right angle. Very good, my brother. So distance is going to equal here in this case. Label, label, label. X1, Y1, X2, Y2. So X2 minus X1 squared plus Y2 minus Y1 squared. So this is the square root of 2 squared, which is 4, plus negative 2 plus 4 is 2. 2 squared is 4. So that's the square root of 8. Remember that 8 breaks down into 4 times 2. Square root of 4 is 2. Square root of 2 equals my x, or FM. So you got to be able to simplify those radicals as well, which is something we reviewed already. Remember that you have to be able to also rationalize. If you get a situation where you have a radical in the denominator, you must rationalize that as well. So please be careful with that, my brothers. Does that make sense so far, gentlemen? May I continue, gentlemen? Okay. Example 3 here. Prove that the medians of the legs of an isosceles triangle are congruent. Okay? The medians of the legs of an isosceles triangle are congruent. So what do I want to do here? I want to prove that AN is congruent to BN. How can I do that? Well, you know that the medians cut these into two perfect halves, correct? And it's an isosceles triangle. So all of those are correct. But I want to prove that the actual distances of AN and BM are congruent. So, AN, the distance of that is going to be label, label, label. X1, Y1, X2, Y2. So 3A minus 0 squared plus B minus 0 squared. That is the square root of 3A squared plus B squared, which is 9A squared plus B squared. For those of you that are tempted, no, that does not equal 3A plus B. No. You can only simplify that if it was 9A squared B squared being multiplied together. Then that would equal 3AB. But if you have a sum, a polynomial like that, you cannot do that. Now let's try BM. BM. Label, 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 label. Let's go X1, Y1, X2, Y2. So I've got 4A minus A squared plus 0 minus B squared. This gives me the square root of 3A squared again, plus negative B squared, which equals the square root of 9A squared plus B squared. And we have proven that those two bad boys are equal by using the distance formula. Again, this is a very simple lesson, but you got to know the formula. If you don't know the formula, you're out of luck. And also label things. Label things. Notice how I labeled AN, how I labeled BM, how I label my X1, Y1, and my X2, Y2. Trust me. I know you guys think, oh, that's easy. I'm not going to waste my time. I'm telling you, that's where you get messed up. You put in the wrong X or you double up on the Y, and then you're out of luck. For nothing. For 2 seconds of labeling, you can jeopardize the wrong answer. Okay? Or the right answer. Thank you. Does that make sense? Okay, and that's it. We're done. So I hope that makes sense. Hope you learned a lot. Have a wonderful day, and thank you very much.